In this video, we're going to use the limit definition of the derivative to find the slope of the tangent line for y equals x cubed plus 1 at x equals 2. So in the corner, let's graph y equals x cubed plus 1. So it's an odd power. When x is greater than 0, y is positive, and when x is less than 0, y is going to be tending negative. When x equals 0, y equals 1. It's going to look like this. It's x cubed just shifted up 1. Right? So this is y, this is x. So at x equals 2, the tangent line is going to look something like this. It's going to be positive. So we will use that to check our answer, to check that it's positive. It's pointing upwards. Okay, and let's remember what the limit definition of the derivative is. F prime of x. It's the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so let's use this. First off, we're going to need f of x plus h. So if y equals x cubed plus 1, and we're saying y is f of x, it's just another way of writing it, then what is f of x plus h? Well, that's plugging in x plus h here, right? So we would have x plus h cubed plus 1. And now, unfortunately, we're going to have to expand this out. So it's x squared plus 2xh plus h squared multiplied by x plus h. So I'm expanding out x plus h cubed. I multiplied two of them together to get this squared polynomial. And there's one more x plus h. I'm just doing it in 2 steps because it's a little easier for me to see. And then I need to multiply these two guys together. So I'm going to get x cubed plus hx squared plus 2x squared h plus 2x h squared plus x h squared plus h cubed plus 1. Okay, so these terms both have an x squared. These terms both have an h squared. So that'll be useful. I can combine those terms. So that's f of x plus h. F of x, that's just x cubed plus 1, right? Nothing changes there. So now let's go ahead and plug in f prime of x is the limit as h approaches 0. So we have f of x plus h. Okay, so that's what we got here. X cubed. Combining these two terms gives me 3h x squared. They both have an x squared. So 2h plus h is 3h, right? And this one, they both have an h squared, so that's 3x h squared plus h cubed plus 1. That is the f of x plus h term minus x cubed plus 1. That's f of x. So let me write, so this is f of x plus h, and this guy, this is f of x. So we're doing f of x plus h minus f of x, right? And then this is all divided by h. So a lot of algebra, right? So this has a positive x cubed and this has a negative x cubed, so those go away. Plus 1 minus 1, Okay, so we have some cancellations. So this is the limit as h approaches 0. I'm left over with a 3xh squared plus 3xh squared plus h cubed all over h. Okay, and if you look at the top, each term has an h, so I can factor out an h. So the limit as h approaches 0 of h times 3x squared plus 3xh plus h squared. And then everything is divided by h. Okay, but now we have an h on top and an h on bottom, so we can cancel those. And what we're left with is the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Okay, so h is approaching 0. That means h squared approaches 0. And if this h approaches 0, then this term approaches 0 too. 3x squared does not have an h, so nothing happens to that. So this limit is equal to 3x squared. So that's f prime of x, right? But we're only concerned with x equals 2. Okay, so f prime of x equals 3x squared. F prime of 2 is equal to 3 times 2 squared, which is 3 times 4, which is 12. And that is the answer. F prime of 2 is the slope of the tangent line at x equals 2. We thought it would be positive, and we got positive 12 as the answer. So that's it. A lot of algebra. You need to identify what f of x plus h is, multiply everything out, group terms, and then you need to subtract, cancel out some terms. And generally in these problems where you're using the limit definition for polynomials, the critical step is factoring out an h from the top, because that allows you to get rid of the h on the bottom. Okay?